I have a question for you. If H₂O₂ reacts with PbO₂ to form PbS, and I were to ask you to construct the overall equation to describe this reaction, which H₂O₂ equation from the data booklet will you choose? Is it this one with the more positive value, or is it this one with the less positive value? To answer this, we'll have to go back to the question, but if you're new here, welcome! I'm TG, your A-level chemistry tutor. Now, the first question you should ask is not which equation to choose, but what is the input and what is the output. So here, H₂O₂ and PbO₂ are the inputs and PbS is the output. Then, because our end goal is to construct the overall equation, we need to first construct the oxidation and reduction half equations before combining them to form the overall equation. So very naturally, our next question will be, what is being oxidized and what is being reduced? In this case, we can clearly see that the oxidation state of Pb is decreased from +4 to +2, so Pb is the one being reduced. Or you can also see how the number of oxygen decreased from PbO₂ to PbS. So this means that H₂O₂ is the one that's oxidized. Now, then we open our data booklet and scan through the list of half equations. Then comes our dilemma again. Which equation do we choose? Now remember, H₂O₂ is the one being oxidized. So this means that it should be the one losing electrons and not the one gaining electrons. So we can very easily just pick this equation. Now pro tip, you can use the acronym LEOA-GERC to remember that lose electron means oxidation, which is also the anode, and gain electron means reduction, which also means it's the cathode. So can you see that the question of which equation do we choose just vanishes from our mind completely? So we already know the oxidation half equation. What about the reduction half equation? So we scan through the data booklet again and we choose this one, right? Wrong. But why? That's because not all substances are present in the data booklet. For very context-specific questions, such as going from PbO₂ to PbS specifically, you must balance this equation yourself manually because there is just no PbS in the data booklet. So you should never blindly just copy anything that has a Pb in the data booklet and expect it to be correct. That is why initially I emphasized on studying the question properly and correctly identifying the inputs and the outputs. Because once you clearly know this, you can know what is being oxidized, what is being reduced, and from here, you can use the data booklet as a tool to see whether it can help you to write out the respective equations. If yes, then all the merrier, but if not, you can always balance the half equations yourself manually. I'll not be going through the process of doing this in this video, but do let me know in the comments if you want me to make a separate follow-up video on this. But there is just one more blind spot that many of you always miss. Say these two equations. Yes, we talked about choosing based on whether it's going to be oxidized or reduced, which is correct. But another way is to pay attention to whether the question says in an acidic medium or things like with potassium hydroxide as the electrolyte. This tells you whether the reaction is taking place in an acidic or alkaline medium, and you should choose the equation accordingly. So hopefully you can clinch more marks, and here are 10 more exam strategies that you will regret not knowing.